Alright, intensive and extensive properties. Yesterday we looked at physical versus chemical. Today we'll look at intensive versus extensive. Yeah, we're switching to this and then we'll go back to the paper. So, physical properties of a substance are the characteristics of a substance that can be used to describe it. So there are two types of physical properties: extensive properties. Extensive properties are directly related to the size or amount of a sample. And then there are intensive properties. Intensive properties are not related to the size or amount of a sample. So extensive are going to be like mass, how much material you actually have. Intensive would be like its color. A yellow bar broken in half is still yellow. There are three primary. Y'all need me to go back? There are three primary extensive properties that are related to the size of a sample. Mass. Mass is related to the amount of matter in a substance. A larger sample has more matter, so mass is extensive. Yes. I will put the video. I'm recording my voice and the PowerPoint, and I'll also make a copy of the PowerPoint. There's also volume. Volume is the amount of space a sample occupies. A smaller sample will take up less space, so volume is extensive property. There's length. Length is simply how long a sample is. Length is simply how long a sample is. Width and height are just lengths. Lengths measure the size of a sample, so it is also an extensive property. So extensive properties don't really tell you the characteristic of the material. They are properties of the material, that specific material, or specific object you're describing, but it doesn't really tell you too much information about them. It's still important to know. If you're making a cake, you'll need to know how much ingredients to add. So it's an important property, but just knowing these properties don't really help identify the chemical being used. There are also 3 secondary extensive properties that are directly related to the mass of the sample. We will learn later on about moles, but the number of moles of a sample is also a measure of the amount of matter. We will learn to convert between grams and moles a little later in the year. We will be using moles quite a lot. So, does anyone know what a mole is in science and chemistry? Does anyone know what a dozen is? What's a dozen? 12. What's a baker's dozen? 13. A mole is 6.022 times 10 to the 23. A little bit bigger than a dozen. It's quite a large number. But so for example, if you had exactly 1 mole, if you had 6.022 times 10 to the 23 atoms of silicon, all those atoms would weigh about 28.1 grams. So we'll be counting, because in chemistry we like to react like 2 hydrogen atoms with 1 oxygen. However, hydrogen is much lighter than oxygen. So if you mix 2 grams of hydrogen with 1 gram of oxygen, you don't have enough oxygen. You had way too much hydrogen. So much later in the year, we'll be learning how to do this. A mole is a very big number. 10 to the 23 is very large. We'll go into that much a little later. Next is energy. The amount of energy in a sample is directly related to its size. The amount of potential and kinetic energy of an object is directly related to the size and mass of the object. Energy is related to size because you can think of it, if I took boiling hot water and spilled a drop on you, yes, it'll burn that spot. But if I poured an entire cup of boiling hot water on you, that's a whole lot more energy. That would be transferred onto you and would cause significantly more damage than a single tiny drop. We won't be going into the chemistry and the physics of that. I think at one point in the year we will be using the top equations, but for the most part we will not. And I'll just remind y'all, kinetic energy is defined as 1/2 times mass times velocity squared. I don't think we ever use gravitational potential energy in chemistry, because most of all chemical reactions, it doesn't matter if you do it on the surface of the Earth versus the surface of Mars. Gravity doesn't affect it. At least not on a high school level. The number of particles is also directly related to grams and moles of a sample. A large sample has more mass, which means it has more atoms and molecules or ions. The number of particles. Moles, I said earlier, is 6.022 times 10 to the 23. Moles and number of particles are basically the same thing. Moles is just a grouping of that amount of particles. Obviously, if you change the number of particles, you change the number of particles. So that's extensive. It's a secondary characteristic. I got these PowerPoints from Miss England, who used to teach chemistry here. So she likes using nice mnemonics and pictures. NVL-min is a mnemonic you can use to help remembering. Mass, volume, length is your primary. Moles, energy, and number of particles are your secondary. These are all your extensive properties. Everything else is going to be intensive. You really only need to write down what's on the bottom left. NVL, min. So there are many intensive properties that are not related to the size of the sample. Because this list is so much larger, you should memorize the previous list first. You should focus on remembering the shorter, extensive list. So I'm only going to go over a few examples because there are so many. Color. Gold has a gold color. If you were to remove some of the gold off of it, it'll still have a gold color. State of matter. If I had liquid water and I spilt some of it, I had a glass of water and I spilt some of it, I still have water. It's still liquid. So it doesn't change on size. Density, how dense something is, also doesn't change on size. And density is the ratio of mass to volume. So it may seem like density should be related to the size of the sample because of this equation, but it's not all. So density is equal to mass divided by volume. If I remove some of the mass, I will also remove some of the volume. If I add some mass to it, I will also increase some of the volume. Because of this, it's density. So if the mass is 17.5, volume is 13 cubic centimeters, density would be 1.35 grams per cubic centimeter. If I reduce the mass from 17.5 grams to 8.75 grams, volume will shrink to 6.5 cubic centimeters. But the density, if you divide those numbers, is still 1.35. Likewise, if I increase the mass, I increase its volume and it stays. Because it's the relationship between mass and volume is independent of both, because it doesn't change on how much you add or subtract away from it, density is an intensive property. Temperature is also intensive. This is because the temperature of a sample depends on its surroundings, not its size. So if you have some ice at 0 degrees Celsius, you remove some ice away, it doesn't immediately change the temperature of the remaining ice. So temperature doesn't change just because you remove some away. So some elements like copper and aluminum can appear in a number of different shapes. A substance that can be drawn out, especially into thin wires, is called ductile. A substance that can be bent and flattened, especially into a thin sheet, is called malleable. Some elements are attracted to magnets, and they can become magnets themselves. It does not matter what size pieces these metals are in, they will always be drawn to the magnet. So if you have a large magnet and you break it in half, you end up making two smaller magnets. Iron, cobalt, and nickel are ferromagnetic. Not only are they attracted to magnets, but they can be turned into permanent magnets themselves. Together, they are known as the iron triad. Everyone good? Alright, let's go through this list and either sort them as intensive or extensive. So color, would it be intensive or extensive? Odor, intensive or extensive? Extensive? So if a skunk were to spray a little, it starts smelling good versus if it sprayed a lot? Does something smell good if you increase the amount of it? So if you had some rotten eggs, would the change the smell change? There's a lot of eggs, and it'd be stronger, but it still smell horrible. It's not related to size. Melting point, mass, boiling point, volume, density, intensive, length, extensive, specific heat, temperature, energy, extensive, state of matter. Now, if you just memorize MBL men, you would have quickly just pulled those out, put it to the right, and everything else went to the left. Everyone good? Alright, let's continue where we left off yesterday. So volume is how much space something takes up. It would be physical. And no, it can't help you identify. And does it change with the amount? Yes. So let's go back over this. Melting point. Was it intensive or extensive? So it would be intensive. Density. Intensive. Specific heat. Intensive. Area. Extensive. Area is based on length. Malleable. Intensive. Ductile. Mass. Flammability. Viscosity. Miscibility. Intensive. Boiling point. Also intensive. Odor. Also intensive. And volume is extensive. So, what do you notice about the relationship between extrinsic properties and properties that change with the amount? So that's basically the definition. Extrinsic. Note that extrinsic and intensive are the same thing. Some people use the word intensive, some people use the word intrinsic or extrinsic to describe them. So extrinsic properties depend on the amount. And what do you notice about the relationship between intrinsic? Intrinsic does not depend on amount. What do you notice about the relationship between extrinsic properties and properties that can be used to identify the substance? You cannot use extrinsic properties to identify the substance. They are external to that substance. And intrinsic, meaning that it's directly a property of that chemical. Intrinsic, if it's intrinsic to you, it's of your nature, is what intrinsic means. Oh, sorry. It's hard to watch the screen and where I'm writing at the same time. So for intrinsic, you can use intrinsic to identify. So the difference between extensive and intensive property is extensive depends on the amount and do not directly tell you anything about the chemical. They are not inherently associated with the chemical, only its shape. Intensive properties can be used to identify them. They do not depend on their shape, and they are inherently properties of that chemical. For the most part, this is already done over the PowerPoint. This is all like the information you could have copied from the PowerPoint. It looks like. So note that extensive and intensive technically are only used to describe physical characteristics. You really wouldn't do extensive and intensive to describe chemical. Any questions? So this will be homework. Should be fairly simple. So a physical change is a change that changes a physical property. A chemical change is one that changes a chemical, the chemical nature.